All right, I'm back. We're still on page 185. We're talking about writing parametric equations for lines. We have a slope, we have a point. There's a lot we can do with that. So let's see what we can do. So, I mean, you don't really need a picture. They can be helpful, I guess. Do it, become a line. So let's say that this is our point, 2, -4. And then our slope is -5/4 or -5/4 or 5/4. All of these are important. So what I'm going to do here is basically the same thing, but I'm going to try to think about it in like a slightly different way, maybe potentially. So I'm going to say initially that delta x is 4, which means delta y would be -5. So my equation is going to be, so we kind of anchor it using 2, -4. And then delta x is 4 times t. And then, oh, it's going to be -5, right? Because delta y over delta x has to be -5/4. Like this. Now, what's this doing? So as t increases, x increases, which means you go this way. Y decreases, which means you go this way. So I'm going to say that we're going right and we're going down. Now, let's think another way about this, right? So delta x is 4. So it's like per unit of time. It's like it will increase by 4 whatevers per unit of time. It's kind of like the velocity. And then delta y is -5. So it's going to decrease by 5 every unit of time. So what I'm going to say is that the velocity vector here is actually 4, -5. And then speed is the magnitude of velocity. So let's say this is the velocity vector. Let's name it v. Okay, we're going to name you v for velocity. Speed is the magnitude of velocity. And so that's going to be the square root of 16 plus 25, so square root of 41. Okay, so that's kind of interesting. We know that we're moving to the right and we're moving down. We're moving right because delta x is positive, moving down because delta y is negative. We know the velocity vector is 4, -5. And we know that the speed is the magnitude, the magnitude of velocity, which is square root of 41. I was going to say 14 for sure, but I switched it up. And then I just undid that for some reason. So that's weird. Let me redo that. Okay, what if we make a different choice? What if we choose delta x is -4 and delta y has to be +5 because delta y over delta x has to be -5/4. So we can do this again, x, y. So our anchor point, the point that it definitely kind of like starts at, is 2, -4, and then -4t plus 5t. So what's happening? If t increases, x decreases, which means we're moving this way. And then if t increases, y increases. So we're moving this way and this way. So we're moving to the left and up. Left, up. It's not possible to move to the right and up based on the slope. To move the right and up, you would need delta x to be positive and delta y to be positive. You need the same sign. Can't get that here. So what's our velocity vector? The velocity is -4, 5. And then the speed is still the same. So that's going to be the magnitude of v is radical of 41. Okay, so what can we do? Let's change it up. Let's say that delta x is 2. So if delta x is 2, and I need all my ratios to be the same, here it was 4 and -5, that gives you -5/4. If I divide delta x by 2 to get 2, I have to divide delta y by 2 also, so -5/2. So this, my velocity vector is going to be half as big, which means its magnitude is going to be half as much. It's going to be 1/2 of radical 41. It's just going slower. So we can write our equations. X equals, so 2 plus 2t. Y is going to be -4 minus 5/2 t. And so we are, in this case, if t increases, x increases, so we're moving right. If t increases, y decreases, so we're moving down. And then our velocity vector is going to be 2, -5/2. And our speed, so think about what we know. We know that this velocity vector that we just found is half of this. It's scalar multiple, 1/2, which means that the velocity, the speed should be half as well. So it's 1/2 of radical 41. So it's really only in the case of things that are moving in a straight line that we can like work out the velocity vector and work out the speed, because otherwise it's going to be variable. We can find a function for it for sure, and then use a calculator to evaluate that, which I've never done before in this level, but now I'm thinking about doing it because that's a really good idea, but that's okay. Can we do a weird one? I don't even want to do a weird one. You know what? I'm gonna just stop here. I'm gonna like leave you with the thought that there's a relationship between the delta x, delta y, and the velocity vector. So the velocity vector for these, for lines with constant velocity, whatever, the velocity vector is delta x, delta y. And then we can find the speed. Speed is going to be the magnitude of velocity. So it's literally just the magnitude of velocity. Like when you're going in a straight line, if you're going with a velocity of like 7, 0, then your speed is 7. If your velocity is -7, 0, so you're just moving along the x-axis, but like to the left, your speed is the absolute value of -7, so 7. So like you already kind of know that, but it's something you gotta like think of things through in different perspectives. Anyway, I'm gonna end this here. I think it's a good place to stop. I'll be back in the next video, and we're gonna keep going. So I will see you then.